Ukrainian drone travels over 1,500 kilometers, crossing Russian airspace undetected before detonating in the heart of Orenburg's helium production complex. This is the farthest confirmed Ukrainian strike inside Russia to date, which is a technical feat with strategic implications. The Orenburg facility sits deep in Russia's interior, over 1,200 kilometers from the Ukrainian border by direct line, and more than 1,500 kilometers by plausible flight path. The plant is a critical node producing helium for both civilian industry and Russia's space and missile programs. Its location, surrounded by open steppe and distant from major military installations, was assumed to be beyond the reach of Ukrainian assets until now. So how did a Ukrainian drone reach so far, and what does this say about the evolving technical contest? The strike was reportedly carried out using a long-range fixed-wing drone, likely a variant of the UJ-22 or similar platform, modified for extended range and autonomous navigation. Ukrainian engineers have adapted commercial and military-grade components, integrating satellite navigation, terrain-following autopilots, and fuel-efficient engines. With a wingspan of roughly 3 meters and a payload capacity of up to 20 kilograms, these drones can cruise at altitudes low enough to evade most radar coverage, while still maintaining the endurance needed for cross-country missions. Russian air defense in the Orenburg region relies primarily on layered systems such as the older S-300 batteries, short-range Panzer S-1 units, and a network of early warning radars. But these defenses are optimized for high-altitude, high-speed threats like ballistic missiles, cruise missiles, or manned aircraft. Low-flying drones constructed with composite materials and small radar cross-sections present a different challenge. The Orenburg's planned security perimeter includes ground patrols and limited electronic surveillance, but no hardened anti-drone shield. Meanwhile, Ukrainian planners exploit gaps in Russia's radar coverage. The vastness of Russia's interior, combined with the finite number of mobile radars and prioritization of assets near Moscow or the front lines, leaves corridors of relative vulnerability. By programming drones to fly nap-of-the-earth profiles, which is hugging the terrain, skirting population centers, and avoiding known radar sites, Ukrainian operators increase the odds of penetration deep into the Russian territory. That said, the technical hurdles remain steep. A drone must autonomously navigate hundreds of kilometers, contend with GPS jamming, and survive harsh weather at the same time. The Orenburg strike suggests Ukrainian teams have refined inertial navigation backups and pre-programmed waypoints, allowing the drone to continue even if satellite signals are lost. The final approach likely relied on visual or terrain matching algorithms to identify the facility and trigger detonation. On the Russian side, the response highlights systemic limitations. Despite significant investment in counter-UAV measures since 2022, Russia's vast geography and the dispersed nature of critical infrastructure mean not every target can be covered at all times. Mobile EW teams and rapid response units are concentrated near the front line or in high-priority urban areas. Orenburg, by contrast, was considered a rear area asset. So by any measure, the strike changes the calculus. The demonstrated range forces Russia to reconsider the vulnerability of sites previously thought untouchable. It also compels a redistribution of air defense assets, stretching already finite resources thinner across a broader area. Why does this matter now? Helium is a strategic commodity for Russia, essential for cooling in missile and space programs. Disruptions at Orenburg could ripple through supply chains, affecting everything from satellite launches to missile maintenance schedules. The psychological effect is equally significant, which is the perception that no facility is truly safe from Ukrainian reach. Meanwhile, the strike signals a maturation of Ukraine's indigenous drone program. Each successful long-range attack provides data for further refinements, better autonomy, improved stealth, and more precise targeting. Russian countermeasures will adapt, but the cost-benefit ratio increasingly favors the attacker, who can build and launch these drones for a fraction of the price of defending every potential target. As always, this is not a moral judgment, it's an analysis of incentives and logistics. Contest is iterative, each strike reveals gaps, and each defense prompts new tactics. The Orenburg operation underscores the shifting balance between offense and defense in the drone age. But now, if we zoom out, the implications extend beyond the single strike. As both sides iterate, the geography of conflict expands in the Russia-Ukraine war. No rear area is truly secure, and the map of vulnerability is redrawn with every successful sortie. The Orenburg drone strike is a case study in how technical adaptation and geographic realities are reshaping the contours of modern warfare. So if you like this kind of content, make sure you like and subscribe for more.